Okay, last time I showed you guys the pi function and also the gamma function, and they are just ways to extend the concept of factorial. And we also saw that 0 factorial is equal to 1, and 1/2 factorial is equal to square root of pi over 2. And today, we will do more. And of course, now the question is, can we actually have some negative factorial? And the answer to that is yes and no. So let me show you guys a yes first. Last time we did the positive 1/2 factorial, right? Why don't we try negative 1/2 factorial? And let me tell you guys first, in fact, this is going to be nicer than the positive 1/2 factorial, okay? So just wait for it. Let's plug in negative 1/2 into this factorial. Of course, I can just plug in negative 1/2 into this x from the pi function, right? So that will be the quicker way. This is the integral from 0 to infinity, t to the negative 1/2 power, and then we have e to the negative t dt. And we just have to work this out now. So to do that, let me write this down in the denominator. So I will keep this as e to the negative t over, this becomes square root of t in the denominator, and then we have the dt right here, of course. And then we'll take a u substitution, that u is equal to square root of t, and square both sides, we get t is equal to u squared, and then differentiate this, dt will be 2u du, okay? And then we will just take this integral from the t world to the u world. So, you know, this is t going from 0 to t goes to infinity, right? When you take that to the u world, u goes from, well, plugging 0 into here, square root of 0 is also 0. So u goes from 0, and when you plug in infinity into here, square root of infinity is still infinity. So u also goes from 0 to infinity. And then we have e negative, this t is u squared, so we have negative u squared power right here, over square root of t is the u, and dt is the 2u du. And now what? Well, as we can see, the u cancelled each other out. And if you would like, we can put the 2 to the front. So we have 2, and that's the integral in the u world from 0 to infinity, and this is just e to the negative u squared du. And by now we should recognize this already, huh? This is just half of the Gaussian integral, right? And we saw that last time as well. So this is the 2 in the front, and this is square root of pi over 2. And in the end, of course, we can cancel the 2, and we get square root of pi. And as I told you, this answer is nicer compared to the positive 1/2 factorial, right? So I can say negative 1/2 factorial wins. And by the way, is there any connection between the negative 1/2 factorial versus the positive 1/2 factorial? The answer to that is yes. I will show you guys this real quick. And I will look at this right here, n factorial, okay? So recall that, I'll just put down recall. This is just one of the properties of n factorial. Now, I will let n equals to 1/2. And you will see, when I plug in 1/2 into here, I get 1/2 factorial. And this is what we did last time already, okay? And then this is equal to, n is 1/2, and here we have 1/2 minus 1, and then we do the factorial. And this right here is square root of pi over 2, right? But let me not write that down yet, because I want to show you guys the next connection. This is just 1/2 factorial, and this is equal to 1/2 times this is negative 1 over 2 factorial, right? And now if you want to figure this out, all I have to do is multiply both sides by 2, isn't it? So now, in the end, we see negative 1/2 factorial is just 2 times that, 2 times positive 1/2 factorial. And of course, we know what this is from last time. So that's square root of pi over 2. And then, of course, they cancel out. So we see that this is equal to square root of pi, right? Negative 1/2 factorial, it's equal to square root of pi, all right? So this right here is pretty much it. And if you do it with this approach, you can easily figure out 3 over 2 factorial, 5 over 2 factorial, 7 over 2 factorial, and also the negative versions, namely negative 3 over 2 factorial, negative 5 over 2 factorial, negative 7 over 2 factorial, etc., etc., okay? In fact, any odd number over 2 factorial, you can do it easily with this kind of formula, okay? And maybe I'll show you guys that general formula next time, because earlier I told you sometimes it's possible for us to have a negative factorial, sometimes not. So let me show you guys an example that we cannot have a negative factorial. What if we have -1 factorial? And maybe you can just try to do like what we did earlier, right? So let's first plug in -1 into this x and see what we get. So this is the integral going from 0 to infinity, and we will have t raised to the -1 power now, and then e to the -t dt. And you can try if you may, but let me just tell you, no matter what we do, we cannot end up with a nice value for this integral. And the deal is, this right here is actually a divergent, okay? And this is what I want to show you. First of all, let me just rewrite this integral as the integral from 0 to infinity, and let me put both of them down to the denominator. So I will just write this down as 1 over t to the +1 power and e to the +t power, and then dt like this. And in fact, this improper integral is both type 1 and type 2 situation. This right here is a type 1 situation because we have infinite interval. It goes from 0 to infinity. That's an infinite interval, right? So that's why it's a type 1 improper situation for the integral. And then it's type 2 because on this interval, we actually have a vertical asymptote. Because when t is equal to 0, 1 over t times e to the t, this becomes 0, 1 over 0, that's the vertical asymptote. That's why it's type 2 as well. But the deal is that, yes, unlike earlier, even though that was also an improper integral with both type 1 and type 2 situations, but that integral actually converges. This one actually diverges, and I don't want to deal with both type 1 and type 2 together. Let me just split this into 2 parts, and hopefully the first part just has the type 1, and hopefully the second part only has the type 2 or things like that, all right? So let me do this for you guys. Let me split this into the integral from 0 to a value, and you can pick any scenario you want, and let me just keep it simple. I will just put on 1. You can put on 17, 25, whatever you want, doesn't matter. And I will still have the 1 over t, e to the t, dt. And then we will have to add the second integral. We have to pick up where we left off. Because I put on 1, so I will have to pick down 1 and then continue to infinity, and we will have the 1 over t e to the t dt, okay? And now the deal is, this integral right here, it's the type 1 situation only because we have infinite interval from 1 to infinity, okay? And you can do a quick comparison test with the integral from 1 to infinity with just 1 over e to the t dt. And you can show that this integral is actually smaller than the integral from 1 to infinity, 1 over e to the t dt. Because that one converges, this right here also converges, okay? So this is good. This right here is a bad guy. This right here is a type 2 situation because we still have the vertical asymptote when t is equal to 0, right? And I'm just going to work this out for you guys. Unfortunately though, we cannot find antiderivative for 1 over t e to the t. So we have to use some kind of comparison test for this. And this is how it works. First of all, because we cannot find an antiderivative for this, let me put down something that we actually know much better, okay? And here is the deal. When we integrate from 0 to 1, we know that if we have 1 over t like that, we can handle that much better. And in fact, that diverges, and this one also diverges, okay? So I'm just going to write this down for you guys. We know that the integral from 0 to 1, 1 over t dt. And the reason that I didn't use 1 over e to the t, because the integral from 0 to 1, 1 over e to the t dt, that's actually a convergent. I have to make sure that I use a divergent, and I will also show this is a divergent as well, okay? And you can check out more of my videos about the comparison test for improper integrals or infinite series. But anyway, this is so much easier to deal with, isn't it? And you can quote the theorem if you would like, but this is not bad to integrate at all. So I will just integrate 1 over t, namely I will get ln of absolute value of t. And I don't need to have the absolute value, but doesn't really matter because 0 to 1 positive, right? But I'll put it down anyway. Now I will plug in 1 into here. This is ln absolute value of 1 and then minus ln absolute value of 0. And technically, we are saying 0 plus, okay? Because we're going from 0 to 1. And we just care about 0 plus. We take the limit right here, okay, technically. Anyway, ln 1 is 0 minus ln 0 plus is negative infinity. And when you do this, you get positive infinity, right? But all in all, we can conclude that this right here, we know it diverges. And now I will use this divergent to show that this is also a divergent. And this is how we are going to do it. Here is the check, okay? And when we are doing comparison test, we have two kinds. One kind is that we can just do compare the inequality. So that's exactly what I did earlier. I just didn't write it down, okay? But if I want to use an inequality to work this out, it's not going to work, okay? But it's okay because we can also do calculus. We can also check the limit, okay? And that's exactly what I'm going to do. I'm going to check the limit as t goes to, well, goes to what? In this case, you have to remember the 0 is the number that causes the vertical asymptote, right? So we'll take the limit as t goes to 0, and technically it's a 0 plus, okay? And just remember, if you are doing the limit comparison test, and in fact, this is the type 2 situation, because once again, we have a vertical asymptote situation on this interval. You take the limit as t goes to that number that caused the vertical asymptote, okay? Anyway, we are going to compare the ratio of this and that. And it doesn't really matter which one you put it on the top or which one you put it on the bottom. Let me just put this one on the top. Well, actually, let me put this one on the top. 1 over t e to the t. And I'll put this one on the bottom. Seriously, doesn't matter which one you put it on the top or on the bottom. Because in the end, you just want to hopefully come with a nice value. By nice, we mean to have a finite value. And that finite value is just anything between 0 and positive infinity, okay? If we can come with that, then we can conclude that both of them have the same convergency. Either they both converge or they both diverge. But anyway, let's just compute this real quick. Well, this is not bad at all. We can just take the limit as t goes to 0 plus. And right here, we can just multiply, t and t on both sides, on top and bottom. So this and that cancel. And we will just have 1 over e to the t. And when t goes to 0 plus, this is just 1 over e to the 0 plus. And 0 is this right here. 0 plus is just the same as 0. E to the 0 is just 1. 1 over 1 is still 1. This is good. And as you can see, this is the finite value. And the best part is that this is 1. Okay, and indicate that this is finite. It's in between of 0 and infinity. So what's happening is that when we compare the value of these two expressions, when x is approaching to 0 plus, we are saying that they are pretty much of the same value, the same size, when you are going toward the vertical asymptote number right here. And especially the same size because we have 1, right? So that means this is just as big as that, vice versa, okay? So we're saying that this is just as big as that because the ratio is 1, right? Especially you take the limit. And because this right here diverge, and technically you can also imagine that this is positive infinity. This also has to be positive infinity. So we can conclude that this is also a divergent, okay? And I will just write down the conclusion right here for you guys. And this is usually the 3 steps that I want my students to show. Put down what you know and do the check. Either inequality or take the limit. And in the end, you draw the conclusion so it can be legitimate. Here's the conclusion. I'm going to state that again. The integral from 0 to 1 over t e to the t dt. This right here also diverges, okay? And remember, they have the same conclusion. If this diverge, you can also show that this diverge if this works out perfectly, okay? So I would like to use the word also diverges. And let's quote the theorem by the limit comparison test. And in fact, this is the type 2 situation for improper integral because we have the vertical asymptote situation, okay? So, what does that mean? This right here diverges, and as I told you guys earlier, this actually converges, but you can imagine a positive infinity plus a positive finite value. In the end, we still end up with positive infinity, right? But we're trying to calculate the value for -1 factorial. That's the main question. And of course, we're trying to calculate a value, right? We're not talking about the limit. This right here, -1 factorial, unfortunately, is undefined. Okay? This right here is undefined. Once again, we're trying to calculate the value of -1 factorial. So do not say that it's equal to infinity or whatsoever, okay? But anyway, hopefully this is clear. And can we also do what we did by using the n factorial relationship? Let's try. So recall, this is exactly what we did earlier as well. When we had n factorial, this is equal to n times n minus 1 factorial, right? I want to come up with -1 factorial. Well, if I put 0 into n, I will have the -1 factorial right here, right? So I will just say, let n equal to 0. And now, this right here, we will have 0 factorial, and this is equal to 0 times 0 minus 1 factorial. Do we know what this is? Yes, 0 factorial is 1, right? And you see this is going to be crazy because we're saying 1 is equal to this 0 times this right here is -1 factorial. Is it possible for us to find a value? Okay, find a value, okay? So that when you multiply this with 0, you end up with 1. It's not possible, right? And you can also imagine you can attempt to divide both sides by 0, but congratulations, you just get a undefined expression anyway. So in the end, we can also see that -1 factorial is undefined, okay? And you can try to do it with -2 factorial, -3 factorial, and things like that. And guess what will happen? You'll get undefined answers for those factorials as well. And let me emphasize this once again. Some people might say -1 factorial should be infinity. But in my opinion, because we cannot find a finite value for -1 factorial from here, and also we know there's no finite value for -1 factorial from here, and when we multiply this by 0, and we end up with 1. That's why I say -1 factorial should be undefined. And also, if you look at the graph for the pi function or the gamma function, you will see that they will have vertical asymptote when you have negative integer factorial. Okay, so it's a bunch of vertical asymptotes. So that's why I say -1 factorial should be undefined. And likewise for -2 factorial, -3 factorial, and so on. Anyway, hopefully you guys like this video, and if you are new to my channel, please subscribe. And before we go, I also want to tell you guys about the sponsor of this video, Brilliant.work. If you guys like interesting advanced mathematics like this, you guys will also like Brilliant.work. It has a lot of interesting and advanced mathematics. You guys can go there and learn. You guys can go there and sign up for a free account so you guys can start to do their problems of the week for free. They also have a lot of interesting and challenging courses you guys can take. If you guys go to the link, brilliant.work/blackpenredpen, not only you guys can support my channel, but if you're one of the first 200 people to sign up for the annual premium subscriptions, you guys can also get 20% off discount. And you see right here, I talk about the pi function, also the gamma function, right? I will have a link to one of the articles that they have in the description for you guys. They also talk about the digamma function. So it has a lot of interesting things that you guys may not have heard before. And in fact, I've been going there a lot to learn more advanced mathematics, and then I make them into videos for you guys. And as you can see, all of this right here, we just need Calc 2 to understand all this. But unfortunately, the -1 factorial or maybe the 1/2 factorial, they were not usually mentioned in the textbooks, right? So Brilliant.work is definitely a great place for everybody who loves math to go and just check out their articles, their pages, their courses, okay? And hopefully you guys like this video, and be sure to check out brilliant.work/blackpenredpen. Thank you guys so much, and as always, that's it.